Hi there, welcome to another burst session. This time we're talking about high yield routines and the routine which one doesn't belong. My name is Janice Nowakowski and I'm the district teacher consultant for mathematics and numeracy in the Richmond School District. So which one doesn't belong is a routine that focuses on looking at similarities and differences, so that comparative thinking. It involves a set of 4 items: shapes, numbers, graphs, etc. And those 4 items are presented to students in a 2x2 grid. And students consider, discuss, and share how these items are the same and how they're different. And then using that knowledge that they're building and the language that they're building around that comparing, they use reasoning and justification to choose one of the items that doesn't belong and why. Some teachers in British Columbia are choosing to not use that terminology about which one doesn't belong, because they all essentially do belong. They have something in common, but which one is the most unique? And so it is up to you in terms of what language you feel comfortable using with your students. This routine originated from Christopher Danielson, who was a college geometry instructor, and he was not very happy with some of the geometry books that were available for young children. And so he wanted to create a geometry book that really provoked people's understanding of shapes and attributes of shape and describing shapes rather than just naming them by whether they're a triangle or a pentagon, etc. For example, the one on the right here would be an example of the type of shape which one doesn't belong, where you have 4 different shapes and you ask students to really think about and describe and compare the attributes of the shapes. Again, this focuses on an element of critical and higher level thinking called comparative thinking, which is really important in mathematics and other areas as well. But students need to develop that language and that ability to compare and categorize numbers, shapes, graphs, patterns, etc. So these are Christopher Danielson's books. He has the children's book, and then he also has a teacher's guide. And both of these focus more specifically on geometry and shape. They're available through Stenhouse Publishing or Pembroke here in Canada, and then the Talking About Math website as well. Also, Mary Barassa, who's a secondary math teacher in Ottawa, Ontario, has curated the Which One Doesn't Belong website. So there it is, the link, wodb.ca. And when you go to that site, as you can see by my little screenshot there, you can choose shapes, numbers, graphs, etc. When you click on that tab, you get a whole collection of Which One Doesn't Belong images that you can then just project or drag to your desktop or print out for students to engage with in different ways. So these can be used across mathematical curricular areas. They really focus on the curricular competencies and mathematical vocabulary and explaining and communicating mathematical thinking. But you might start a discussion by projecting one so the whole class can see and just say, what do you notice? And then how are they alike? How are they the same? How are they different? And have students point out some of those similarities and differences. And then maybe they turn and talk at their groups or to a partner to think about, if you had to just choose one, which one is the most different, or which one doesn't belong, or which one is the most unique, however you would like to phrase it. And then they need to explain and justify their choice. And that's where all sorts of mathematical thinking and language is embedded in this particular routine. So here's an example from the WODB site, and I've used this one with grade 2 students all the way through grade 9 students, because different ages and experiences will bring different knowledge and understanding that they bring to the WODB. So we see 4 numbers here presented, and you can think, well, how are they all the same? Well, they're all numbers. They're all numbers under 50. So those are some ways that they're the same, that students might say that they're the same. And then how are they different? Well, automatically there's one that's visually different. It's a 1-digit number. The rest are 2-digit numbers, or have numbers that are in the tens place as well as the ones place. And again, all sorts of different language will come up, and I'm sure you're looking at them and you're noticing some things. Some of the things that students have said is that only one is even and the others are odd. So thinking about odd and even numbers and how you can check for understanding around that when students bring that up. Some are prime numbers and some are not prime numbers, or they're composite numbers. Some are square numbers. So 9 and 16 and 25 can all be they're square numbers: 3 times 3, 4 times 4, 5 times 5, etc. So again, different ages of students will notice different things. There's also something called a digital sum or a digital root. And for those grade 7, 8, and 9 students who know number properties and properties for division, they know that when you add 2 digits together in a 2-digit number or a 3-digit number, you add 3 digits, you get a digital sum. So for 16, the digital sum is 7. And that when it's 1 digit, then it's called a digital root. And so again, different students will bring different knowledge to a which one doesn't belong and to that discussion. Here's an example of one that I often use just to sort of establish the routine, because it's one that all students, regardless of grade or age, can access in some way, because one of those dice is a different color. So a student could say, well, that one doesn't belong, or that one's the most unique because it's blue. And that's not wrong. That is correct. And so it doesn't necessarily have to be mathematical. A mathematical access point, it could be a visual access point for all students as well. And, here we've got, some representations of 5. You have some that are dots and some that are one that's a symbol, etc. So different sizes as well. So all sorts of different attributes or things that students could notice and describe. And then we have some shapes again. These are all polygons. Again, visually, one is shaded gray and the others are not. So again, that's an access point for some students. We have 4 that are quadrilaterals, 4 sides. Again, some students may say 4 sides, but you may notice that some students say quadrilaterals. And so again, different access points and building vocabulary and language across the grades. And then as our students get older, there's also a whole section on the website that has different types of graphs. And so you can, different types of relationships that you can look for, and again, have students describe and make inferences around what those graphs could be about. So these are some of the comments over the years in Richmond where we've been using this routine in schools, from teachers that have used it. Every child has an entry point. The mathematics that they uncover always surprises me. I've had grade 2 students talk about prime numbers, and the teacher said, well, we haven't talked about primes. I'm like, well, the student might have read about primes or talked to their parents about it. Students bring all sorts of knowledge into the classroom, so they're full of surprises. And again, they really like working together collaboratively, either in pairs or in groups, to share and compare their thinking. And again, really focuses on that mathematical vocabulary and language, because so much of math is around communication. So providing opportunities for students to talk about math whenever we can is really important. These are just some of the curriculum connections. Again, it would depend on what you chose in terms of numbers or shapes or graphs. But you can see the curricular competencies on the left, using reasoning, visualizing, communicating, language and vocabulary, explaining and justifying, making connections. And then again, the content on the right are just some of the examples from what I've shown you, but there would be many different examples of content connections depending on the which one doesn't belong that you do. These are some ways that teachers in Richmond have used which one doesn't belong. This was at a grade 5-6 class at Cook, where the teacher printed off some of the images and put them in plastic sleeves, thinking that the students would use whiteboard markers to annotate and circle and write notes on them, but they wanted to write on their clipboards instead. So that's what happened, because they moved from table to table. This was pre-COVID. So again, just an idea, you could introduce one as a whole class on the screen, and then have things set out at tables for students to work together and notice and wonder together. This was something a kindergarten and grade 1 teacher did, is she printed out a WODB and put it on the board on Monday. And then on Friday, they did it together as a class, but it gave the students lots of time to notice, to talk to each other, to listen in on others' conversations, and build some questions and wonder and curiosity about the which one doesn't belong before they did the whole class discussion later in the week. And then you can create your own WODBs. They don't have to be, electronic images. They can be 3-dimensional as well. So I happened to find this 4-section tray and was very excited to find that, but you could make one or build one, or use cardboard. And use materials that you have, math materials that you have from around the class. In this case, I've used 3-dimensional forms to talk about the attributes of shapes. And then I'm also introducing it is using, found objects from your classroom to have students notice and describe some of those shape attributes. So this was again in a kindergarten and grade 1 classroom, and we just put tape down on the carpet, just the painter's tape, so it comes off really easily. And then, pulled some things to talk about rounded edges and curved edges and straight edges and wide and narrow and tall and depth and all that vocabulary that comes around describing shapes. And then during math workshop, when students went around and worked on continued to work and think about different ideas around shape and attributes, we just put tape on some of the tables and students found different objects and set up a WODB and then had those conversations with their classmates. And then this was in a grade 2-3 class over at Woodward, and we did a couple WODBs around shapes together projected on the screen. And then the students collected materials from their classroom and created their own WODBs in their notebook. So you can see we haven't worried about drawing with rulers or anything. They've just done their, drawn a square and then divided it into 4 parts and then chosen their shapes and then described the attributes of the different shapes. And then this is in a grade 6-7 class over at KID, and we did a whole lesson around WODB. So they were looking at mixed numbers, improper fractions, comparing and ordering fractions in different ways, decomposing fractions. And so we began with a WODB, which you can see on the top left there. And I strategically chose different types of fractions for students to think about. We did that as a whole class. And then I did a little mini lesson, probably for about 10 minutes or so, where we went over some of that language again to make sure students felt confident about mixed numbers, improper fractions, how to move flexibly and fluently back and forth between different types of fractions, and the vocabulary that they needed for that. And then the students worked in triads to create their own WODBs with specific criteria. So there had to be one mixed number, one improper fraction, one proper fraction, etc. And then they traded them around and had to discuss and solve each other's WODBs. And that was sort of the end of that. That was an hour or more of math around this idea of comparing and looking at fractions in different ways. And then you can also use WODB in other areas of learning. In science, you can, art with images or with materials, in social studies with different images or maps. But here we've got, this was in the fall, and you can just see we've used tape on tables and use gourds and use leaves and have students, observe and look closely and notice and describe the different attributes and compare those. And then this is just an example from Sarah Vanderworf, who has a great website for those of you that are intermediate and secondary teachers. But she did a school bulletin board where she put up some different WODBs. She just changed out the numbers or the shapes each week. And then there was a little pocket with Post-it notes, and then students had to write their reasons why they thought that one, which particular number didn't belong. So it became an interactive experience. In the school, it builds a school-wide mathematical community, and students, were debating and discussing in the hallway with each other, which, again, that doesn't always happen for math in hallways. So it's just a great idea that I thought I would pass on. We do have the WODB posters available on the district math blog and in the portal, both in English and en français, and it has the website as well, and just an image that I had taken. And then the hashtag, if you're on Twitter or social media, is WODB. So as we finish this session today, I'd just like you to think about how you will use this high yield instructional routine with your students.